All right, so we've talked about classical, that is computational accounts of the mind, mental architecture, and connectionist systems, which were a different approach, intended to be a little bit more based on how we think brains work or neurons work. So now we're going to debate these. We're going to start off with a discussion of how representation works in connectionism. Remember, the beginning of this entire discussion about mental architectures relied on this idea of mental representations. Somehow, you can think about going to the refrigerator and grabbing a beer. You can think about a pink elephant, even though you've never seen one. You can represent it in your mind. So that seems to be an important part of what we do. We somehow process the world. We can think about even fictional entities we can represent. Okay, made sense in a computer approach. We thought about that for a bit in last week's class. And now we're going to figure out how it makes sense in a connectionist system. And we're going to see that there's problems, and those are going to lead to some arguments against connectionism. And then we're going to see if we can reconcile these two views that I've talked about so far. So if you get the idea of a connectionist system, it's a series of inputs and outputs, right? There's a network that has a knowledge that you could represent maybe as a pattern of weights and thresholds for how it's going to treat new information. So let's say our minds are connectionist systems. Let's say connectionists are correct, and you're thinking about coffee. There's going to be some way that your neurons activate. There's going to be some discrete way that your mind puts together the coffee representation, and it's going to be a series of, it could be a couple of things. One of them would be a series of weights for your for when a node would fire to another node, right? The idea being there's a threshold for how much information, how much of caffeine you need to smell or taste, or brown liquid you need to see before your brain recognizes it, before your mind recognizes it as coffee. And so we think, okay, well, we can talk about coffee all we want. We do that all the time. Maybe some of us more than others. But in a connectionist system, there is no single place where you can find a coffee. There's no single neuron that is the coffee neuron. There's no single set of neurons that do it. Instead, the entire network in a certain way of activation is coffee. But the interesting thing about it is you can actually think about representing coffee in different ways. And once you start thinking about it that way, a connectionist system will have completely different activation patterns depending on how you're using coffee. Coffee in a cup might be one set of activation patterns, one set of inputs, one set of thresholds that a node will respond, that nodes respond to, whereas coffee bean might be something completely different that has no overlap. So there's not going to be a single neuron, there's not going to be anything. So there's going to be some problems that come up from this way of setting up a mental architecture. First, it seems like we have individual representations. You think of a particular coffee, a particular beer you're going to get. So we have individual representations. But there's no storage that is individual. There's no part of your mind where coffee is stored. There's no part of it that way if you just zap that particular neuron, I keep switching between minds and brains because I think a lot of us want to do that, and you might be doing that as well. But there's no single thing that I could zap you. I'd have to like zap you in a particular kind of way to produce either coffee in a cup or coffee bean, and those might be entirely different ways of zapping you. So if I want to find out how a network, computer network, or your brain is representing coffee in general, there might not actually be any similarity. There might not be commonalities across different networks at all. So you might represent coffee with one set of activation patterns, and I would do it in a completely different way. So, okay. Let's say we can vastly oversimplify a connectionist network and now say that there is a single node that will, when it is triggered by dogs, like there's a dog detection node that receives input that says, oh, that was a dog. It can process a relation, and that relation can go to another noun. You'll see that in a semantic network, with just a couple of nouns and actually one verb in this case, you can represent many different propositions. Dogs have fur, dogs have paws, cats have fur, right? And so what this shows, you can trace it with your finger if you want, that even in this particular case, you're tracing an entire set of different thoughts to get into propositions. Very similar propositions will look very different in the system. And they might look very, 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 very different when you have 16 propositions rather than 3. So you're trying to build up a network system, you're trying to build it up, you're trying to make this connectionist system be able to represent all of these different sentences, so that depending on the world that you're in, dogs have fur, it will reveal that cats have fleas is true, but fish have fleas is false. So you're going to have to introduce some hidden nodes. You're going to have to introduce all of the stuff we talked about in the last video to try to get the right set of weights in your system to produce all of the true sentences and all of the true sentences as true and all of the false sentences as false. But the moment you add a new proposition, so you've trained this network, it's great, it works, gives you all true answers and all that you want to be true and all false answers that you want to be false. The moment you add another proposition, you're going to actually have to adjust every part of the network, which is weird. Because it doesn't seem like the moment you learn one single thing in school, you have to adjust everything you've ever learned. You don't have to change how you think about your mother, right? So that seems a little bit weird. All right, so there's going to be some problems when it comes to representation for connectionists. The first is it's the network and it encodes every single proposition. We just saw that those 16 different propositions, they were all encoded by the network. No single proposition was represented by a single thing, even though as you perceive dogs, it might fire and give you, or the different nodes might affect each other in such a way to yield all of the sentences that are true that follow from dogs. Which is weird, because let's say you have the belief that cats have fleas and it's going to affect what you buy at the store. It actually means that every part of the network in that belief system, every part of that is causing your behavior. So fish have gills causes you to buy flea medicine for your cat. If every proposition you believe is jointly represented, every proposition is invoked with every explanation. That's weird. It's supposed to sound weird to you. That's weird. And then I've already mentioned this, but my view of coffee and your view of coffee, even once you've learned a new sentence like fish have eggs, your network is going to represent coffee differently. It's going to store it differently. So that's strange too. Connectionist systems are pretty weird. So we want to think that our beliefs cause actions. But what about what is going to be the cause in a connectionist system? Is it going to be a region of network space? I'm not sure how that would work. How can the kinds of things that would activate when when cats have fleas, how could we say that that is a cause all the time? Is it activation patterns? Well, those can be very, very idiosyncratic, so that even the exact same belief could have different hidden units activating in different ways. Remember, hidden units are essential to connectionist systems because those are how you can adjust all of the different inputs in such a way as to produce lots of separate beliefs. Is it a repeated pattern or some broad similarity across networks? But that, you're never going to draw precise and consistent connections. It's going to be either very vague or imprecise or arbitrary or false. So that's weird. We want to think that your beliefs cause your actions somehow. You believe there's a beer in the fridge, so you get up and go and grab a beer from the fridge. But if your beliefs are structured in a connectionist way, then your belief that fish have gills also caused you to go to the fridge to get the beer. That's weird. So here's the argument then. Psychological explanations depend upon mental states that are functionally discrete, semantically valuable, and causally efficacious. Connectionist systems don't have that. Therefore, either they're right and how we think about our thoughts is wrong, or connectionist systems are wrong. Let's twist the knife a little bit more. You guys remember the translation room? You were in a room getting all of this input, and then it didn't seem like you actually understood anything. Well, connectionist system seems to have avoided this because it doesn't have anything like this. It's not algorithmic in the same way. Except actually you could imagine you could build up the exact same thing. I don't know why John Searle, who came up with this, keeps picking on the Chinese language. I think it's because it's a language that is so differently structured than English that most of his readers won't understand it. So he says, all right, imagine a bunch of people are just hanging out and moving around in the exact same positions as to produce the outputs. Like don't even imagine a gymnasium. Say that you are, on a beach trying to stand in exactly the way to spell out the word help. but you don't know that that's what you're doing. So you're just told to go stand in a certain spot. It will produce the word help, but nobody in that beach that was all standing in such a way as to produce a giant word so that an airplane flying overhead could read it. None of you understood what was going on. Therefore, if you're just doing syntactic manipulation, there's no way you can have meaningful thought. Cool. You could just rehearse all of the responses to the translation room here. But the point is that if you believe that translation room is a good attack against a computational theory of mind, then there's a version of it that can also attack connectionist systems. So one of the big advocates of a computational theory of mind, the developer of the language of thought hypothesis that I quickly talked about, to try to draw a link between syntax, that is the formal structures of how your brain is organized, how your mind is organized, and semantics, what the world means, what the words you say mean, what your thoughts mean. Jerry Fodor has a couple of arguments that he thinks are pretty knockout against connectionism. He thinks that the connectionist system is just an implementation level. So think about Marr, we talked about him a while back. Implementations are the more basic level of facts, right? So a computer program can implement language, or a human brain could implement languages. Your chair can be implemented by wood or by metal or whatever. So what Fodor thinks is important to talk about is not what is, like, it's not the hardware that matters, it's the software. So if connectionist systems are doing everything that the computational theory of mind is doing, then it just is a computation. It just is a Turing machine. It's especially bad because we run all of our connectionist algorithms, all of our neural networks, we run them on like computers, right? Like which are explicit Turing machines. So, so it doesn't seem like there's something fundamentally different going on. Okay. So let's spell out these arguments that Fodor and Pilishin raise against connectionist systems. First, cognitive capacities are productive, but connectionist networks are not. So you can think of an infinite number of thoughts, whereas every new thought that you have in a connectionist system affects every other thought. You can't come up with new ones each on the fly, sort of. Cognitive capacities are compositional. This one's the one that they're going to really spend some time on. So there's a non-arbitrary, systematic way of relating ideas to each other. But the connectionist systems are not. So I showed you that with coffee bean and coffee cup. You can have a completely different firing process that produces I love Lucy and Lucy is loved by me, even though they are compositionally identical. Those reflect the exact same thought. Finally, our thoughts are coherent. We don't contradict each other every day. Whereas a connectionist system, you can easily train a connectionist system to be incoherent. You could easily make it produce cats have fur, dogs have fur, neither dogs nor cats have fur, which is crazy. I mean, it's not that crazy, actually. That one actually makes a little bit more sense. You can imagine a world where the combination of them doesn't have fur. But the point is, the connectionist network doesn't know what the hell's going on. There's just like, it's just manipulating little aspects. So let's do some linguistics. Here's a noun, a verb, and a noun. Joni loves Chachi. That is a relational thing, right? So X has a relation to Y. Everyone hates Chris. Johnny loves Chachi. X has a relation to Y. We can plug and play whatever we want. We can rotate these as well. Y has the relation to X. We can change these relations. And if we keep the truth value the same, we can accept them in our minds. It's not difficult. Like you don't have to like scratch your head when I say I love Lucy and Lucy is loved by me. Like that does not make you completely question everything you believe. Whereas a connectionist system needs to process those in entirely different ways. So compositionality is an aspect of language and presumably thought, such that you can produce coherent sorts of translations or transmutations of concepts. Turtles are slower than rabbits, rabbits are slower than Ferraris, turtles are slower than Ferraris. You can train a connectionist network to do every version of that, even including inconsistent ones. So here's the dilemma they're pushing. They're saying either artificial neural networks contain representations that are separable and recombinable in the way they think that thoughts and languages are, or they don't. If they do, like connectionist systems just are a particular way of implementing a physical symbol systems approach. We're exactly back to the computational, like we thought we were going to networks, but no, it's computers again. We're back to computers. We're back to an algorithm again. On the other hand, if we don't have such representations, then that doesn't seem to reflect how anything that we care about as a mind works. They're not information processing. Either way, neural networks, connectionist systems are not serious competitors, they argue, to physical symbol systems. So here's a couple of solutions. Bite the bullet and accept that mental representations aren't structured the way we think they are. Accept all of those weird consequences that I told you, where like learning that fish have gills forces you to rethink how your mother raised you. Sorry. Or in decreasing order of severity for the connectionist, you can treat it as an implementation level approach, whereas we're classical, we're computational at some other approach, like algorithmically or functionally. What that just means is your brain just is a computer in a roundabout way. Connectionist systems are just a roundabout way of producing computer-like outcomes. Then we can think that, okay, maybe mental processes are connectionist networks, but representations, that is the problematic part that we were talking about, those are classically structured. Everything else is connectionist. If that's the case, representations are what we cared about, or what some people cared about anyway. Why not just think of the mind as a computer? And then that's a version of just giving up on connectionism. There's a couple of responses we can give. The connectionist doesn't actually have to agree with any of these arguments. They might push back and say, actually, how connectionist networks represent thoughts might make more sense than how the computer represents it. We're not as productive in our sentences as computational people think. There's some sentences that we can put together that are just nonsensical or can lose us very quickly. Like the horse raised past the barn fell. It's a garden path sentence. It's one of the famous ones that there's like so many ways of reading that. And in fact, you can see how it's actually problematic to produce these sentences this way. Next, so we're talking about inferential coherence. It's not obvious that we make pretty systematic mistakes all the time that are not what logicians would tell us to do. We have very regular and predictable systematic errors in our cognition. That's what marketing is trying to exploit. And then lastly, maybe language isn't as compositional as Fodor and Pilishin were arguing. John kicked the bucket might just not be the same thing as the bucket was kicked by John, right? One of those implies causation. There's like a whole thing going on there. The sentence is foregrounding some things. There's like a lot of stuff going on. And then even then, you know, this is just representations and language. There's a bunch of other stuff that happens in the mind, like perception, memory, a bunch of other stuff is going on. We shouldn't be focused on these particular things. I like parodies because I think they can reveal where we've gone wrong in some of our reasoning. So here's a parody from David Chalmers. Fodor and Pilishin are arguing that compositionality is super important and connectionist systems can't do it, therefore we should be classical computationalists. Says, no, you know what? Imagine a behaviorist shows up and says the same thing about cognitive science writ large. Says, hey, you recognize classical conditioning is important, but you don't take that into account. There is no guarantee of stimulus responses in any of these things. Therefore, you can either ignore all of the good evidence and have that we've produced and have a defective theory of mind, or just accept that your cognitivist approach is just another way of implementing our behaviorist agenda. It's ridiculous. We're focusing a lot on language and a lot on certain ways of structuring belief, but that's not all the mind does. And maybe the computational approach really works there. The connectionist system approach works in other things. We'll keep that in mind as I go to the next video. This one has gone on a bit long, so I'll finish this up in the next video.